Okay, new unit, exponent functions, okay. Determine if each function is an example of exponential growth or decay. There's two ways you can go about this, okay. Y equals 2 times 4 to the power of x. That's a power operation. It's up to the top right, means a power. Now, here's the first way, okay. You can make an input-output table and just go 0, 1, 2. So if I take 2 times 4 to the 0 power, it's going to be 2 because 4 to the 0 power is 1, and then 2 times 1 is 2. Now if you put a 1 in there, okay, 4 to the 1's 4 times 2 is 8. Put a 2 in there, 32. So obviously that's growth because it's going up. Now I'm going to jump down here and write y equals 3 times 0.25 to the x power. The independent variable goes 0, 1, 2. Okay. First one's going to be 3 because anything that's 0 power is 1. Zero 0.75. I think this is a decay. And you can clearly see it's decaying. Okay, so decay. Now, here's a quicker way to do that without the table. If you want to do the table, that's fine. Y equals 5 to the x power. And by the way, here's why this is growth, because this base number here, 4, that's greater than 1. If that base of the x exponent's greater than 1, it's growth. 0.25 is less than 1 whole, so that's why it's decay. So here, the base of the exponent, the 5, is greater than 1, so we know that that's going to be growth. Okay, the base of the exponent here, 1/4, that's less than 1 whole. So that's going to be an example of decay. Now, but I will have people, if they do it that way, mess up the next problem. 25/7 times 7/5 to the x power. Remember, I care about the exponent base, not the front multiplier. Okay, 7 over 5. A lot of people see fraction and say, oh, that's less than 1. No, 7 over 5, you divide it, you'll see it's greater than 1. So that's going to be growth. Okay, basically, I don't care about the front multiplier. It means pretty much nothing when doing this. Okay, base is 10. That's greater than 1. So that's growth. Then 2.25 times 1/3 to the x power. Okay, that exponent is less than 1. It is a fraction, but 1 over 3, you know. Improper fraction when the top's bigger is greater than 1. Now it's not, so that's going to be decay. Okay, those first problems are easy. If you want to pause the video and go in the back and do 1 through 7, should be pretty easy. Okay. Alright, now we're going to graph some exponent functions. These do not take a long time to graph. Okay, y equals base 2 to the x power. Okay, so one thing you're going to want to do is determine whether it's going to be growth or decay. So that base is greater than 1, so that's going to be growth. Now, the reason why we want to do that, because on a growth, okay, you're going to want to start your table with 2, 1, 0, -1, -2. Now, if it's decay, you're going to go -2, -1, 0, 1, 2. Okay? And you're going to want to underline this and pick an extreme value. I usually pick -10, but that's just me. Okay? Okay, so 2 to the second's 4. Now, incidentally enough, if we know that 2 goes with 4 in an exponent function, we also can find -2 very quickly, and here's how. If I would put a -2 in for 4, remember, to make a negative exponent into a positive, you can simply just put a 1 over the top of it, because remember we said if it's top it goes bottom and it makes it positive. So that ends up being 1 over 4. So that's not coincidental. If this is 4, this can be 1/4. And then 2 to the 1 is 2, so this would be 1 over 2. And anything is 0 powers 1. Now, I want you to just do a caret on your calculator with the -10. So that's that's so close to 0. It's close to the integer 0, so just put approx 0. Okay? That's important. So now start graphing. So 2, 4, 1, 2, 0, 1. Then with those fractions, you just get closer to the line. Okay? Now, you go up this way, and it's approximately 0 when you do -10. All that means is that this will never cross 0. Okay? You just keep getting infinitely closer to 0 without crossing it. Don't cross the middle line. Okay? Now next one, y equals 1/3 to the x power. So this is going to be decay now. So decay, what I want to do with my table is go -2, -1, 0, 1, 2, and then the extreme I'm going to put is 10. Okay, positive 10 this time. So decay, I kind of flip the table around. Okay, so I don't even care if you do this on a calculator. Okay, so 1ABC3 caret -2 is 9. So if that's 9, this has got to be 1/9. Okay, now I'll explain how that's 9. Okay, so if you have a negative power, it's already a fraction. So what these can do to make it positive is the 3 and the 1 would switch places, and then 3 to the second's 9, and then having a 1 to the second's 1. 9 over 1 is 9. So that's why that's 9. And the 2 power would just be 1 to the second 1, 3 to the second 9. Now, 1/3 to the -1 is going to be 3. And this would be 1 over 3. Now anything to the 0 power is going to be 1. Okay. Now I do want you to put the 10 in. So 1ABC3 to the power of 10, approximately 0. Okay. Okay, so -2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 3, 1, 2, 3, 0, 1. And again, all these do is get close to the axis. But since it's approximately 0 when we go way forward, that means all it does is get just closer where it hugs up against it. You need arrows on both ends because this does go on for eternity. The domain is all. Okay, the range isn't going to be all, as we'll see, but we don't need to do domain and range. And by the way, let me go back to this. The reason the negative first power gave me an output of 3 is because if I put a -1 in for x to make it positive, we would flip these. That'd be 3 over 1, which is 3. Okay. Okay, next problem, y equals 5 to the x power. Okay, 5 that's a growth. So when it's growth, I want to start positive and go negative. Just trust me, this does work. And then -10 will be the extreme. You're like, why do we have to do that -10? Because that'll tell you what line you can't cross. Okay. So 5 caret 2, 25. So if that's 25, this is going to be 1 over 25. 5 to the first is 5. That'd be 1/5, and then 1. Now again, if I take 5 to the -10th power, that's approximately 0. Okay? It never crosses 0 or even touches it. It just approximates it to it. Okay, so I'm going to need to go by 5s on the y-axis here. So I go 2, 25, 1, 5, okay, 0, 1. Then all you do with those fractions is just get closer. Don't overthink the fractions. Just get closer to the line. Okay, y equals base 1/5 to the x power. Okay, so that's a decay. So now I'm going to flip my graph and start with the negatives. Now for my extreme, I'll go 10, positive 10. Okay, so 1ABC5 caret -2, that's 25. I'll explain again how that's, and this is 1 over 25. I'll explain again why that is. Because remember, if you have a negative power, if you already have a fraction, okay, you can flip that to 5 over 1, okay, and then it becomes a positive. So 5 to the second's 25, 1 to the second's 1, that's 25, okay. And this is going to be 5, okay. You can use a calculator, go for it, okay. It's 5, because it would go to 5 over 1 to the positive 1, so 5, and then 1/5, and then 1. That's going to be 0 again, approximately 0. Approx. Okay, so -225. So -2, 5, 10, 15, 20, 25. So again, it forms that. Okay, pause the video and you can do numbers 10, 11, or 8 and 9. I'll tell you what, just do, let's cross out this and this and just do the back side, okay? I don't need to waste your time with that, a lot of your time. We're going to be doing that more extensively tomorrow anyway. Now, back to the examples. Pause the video and do those graphs and come back here. I don't need to talk about this, okay? Now, we're going to do some easy story problems with exponent functions. They don't take long. The owner of an original copy of a comic book sold at an auction in the year 2005. The owner bought the book in 1980 for $55. The value of the comic book increased at a rate of 3% each year. How much should the comic book be sold for? Now we're back to 2 units. So finally we get some problem solving this semester, which I like. X is years, Y is dollars, okay? So dollars per year. Remember, time is X, okay, and then the other unit's Y. Now, we don't have a dollars per year. It doesn't exist. Instead, we have a percent per year. Now, a couple things. Now, just write the percent in. It will not be a linear function. That means I'm not going to make a line, okay? Instead, it's an exponent function. Put expo. Now, in an exponent function, the first thing you want to do is identify your factor, okay? Here's how you identify that. You take 100% and it increased 3%, so you add 3%. So that would be 103%. Now move the decimal twice. So the factor is 1.03. Now if I make that table, and also with expo I don't make a line or anything like that. Don't have to, okay? So X, Y, X is years, Y is money, okay? So let's go 0, 1, 2, and let's determine what's happening. So the money begins at $55, okay? Now, instead of adding, you're going to multiply by your factor, 1.03, so we won't be adding. So after 1 year, 55 times 1.03 is $56.65. And then times 1.03, $58, and just put 35 cents. If you put 34, that's fine. Okay, now, how many years is this? Well, they don't tell me the years. Well, here's the deal. You take the years and you subtract them. So you take 2005 minus 1980, and that's 25. So 25 years, and then we're finding the money amount. Now, we don't need to make the table really. On an expo function, I'm going to set this up. It's going to be a times b to the x power equals y. Okay? Now, a, b, and x. That's what we're going to do today. Okay? Or actually, just do a and b now. A is where the y started. Y is money. It started at 55. B is the factor, 1.03. So write 55 times 1.03 to the x power equals y. Now we're solving for the money, so we're solving for the y. That means x has to be equal to the years, which is going to be 25, okay? So I cross that out, put 25, and I solve it. Y is by itself, okay? So it's not like it has any operations with it. So I just go find the other side. Y times 1.03 to the 25th power. If it's a money, put 115.16 or 0.15. I don't really care, okay? So $115.16. Now I'm not going to be messing around with the table here on an expo because it lengthens a process, makes it longer than it needs to be. You put $125 in a savings account that earns 2% interest each year. You make no deposits or withdrawals. How much will our investment be worth in 10 years? So let's go dollars in years. Years is X, dollars is Y. So per. Dollars per year. We don't have a dollars per year, it's a percent per year, and it's going to be 2%. So its interest is adding. It'd be. So that tells us this is an expo and it's a factor. Excuse me, I shouldn't have said adding. Okay, I spoke too soon. So factor equals, you take 100% and you add 2%. So 102%, that's 1.02. Okay, now just go right to your A times B to the X power equals Y. Now, A is where the Y started at. Dollars is Y, dollars is Y, dollars is Y. So what dollars did we start at? We started at 125. Then my B is easy to find. It's the 1.02, okay? So it'd be 125 times 1.02, power of X equals Y. So I'm solving for dollars. Dollars is Y, so I'm solve for that. So I got to replace X. X equals 10. Years is X. We have 10 years. So 125 times 1.02 to the 10th power equals Y. And Y is easy to solve for. We're going to come to problems later this unit where we have to solve for the X, the exponent, which nobody knows how to do. So $152.37. Okay, next problem, 2004. A person purchased a car for $25,000. The value of the car decreased by 14% annually. That's per year. Calculate the car's value in the year 2012. So we got dollars in years. X is years, Y is dollars. So per, dollars per year. It's a percent per year, okay? So the percent's 14%. So that tells me we have an exponent function, and I got to know the factor if it's an exponent function. So I take 100% minus 14%. Now I'm minusing because it decreased instead of adding it. Other than that, it's the same thing. 86%. So 0.86 is my exponent factor. So what do I do with an exponent factor? I put it into A times B to the X power equals Y. Now you're going to want to know what A and B are, okay? A is where the Y starts at, okay? A is where the Y starts at. Y is money. The money starts at $25,000. B is the 0.86. Okay, because it equals Y. Y, the A is where the money starts at, the Y starting point. So A, 25,000. Then B is the 0.86 to the X power equals Y. Okay. Okay, now I have to find the money. Money is Y. I am solving for the Y. Circle the letter you're solving for, okay? And then we have to set the X equal to how many years we have. And we have, well, subtract the years. 2012 minus 2004 is 8. Okay, so if they give you 2 year you just find, you have to find the year range, you just subtract them. So that is an 8th power, okay? X equals 8. Didn't give you very much space here. To the 8th power equals y. So I take 25,000 times 0.86 to the 8th power, $7,480.45. Okay, last problem. There are 128 teams at the start of a citywide 3-on-3 basketball tournament. 50% of the teams are eliminated each round. How many teams are left at the beginning of the 4th round? So you have teams and rounds. The rounds is the time unit. Teams is the y unit. Now some of you could probably do this without this stuff. Half, okay, it says 50%. Okay, so that's an expo. And the factor, what does eliminated mean? Probably subtract instead of add, okay? 50%. Move the decimal twice, so it's going to be 0.50. Okay, then that tells me I can write my function. A times b to the x power equals y. Here I'll be more specific with what a is. A is where the y begins at, okay? It's where y begins. So y is teams. How many teams do we begin with? 128. That's your A. B is the 0.50. So it's going to be 128 times 0.50 to the x power equals y. Now that's the equation, that's the function, now we solve it. So I'm finding the teams, so I'm solving for the teams, the y. We need to replace the x in with how many rounds. Now it's not 4, we haven't started the 4th round, so x is actually 3. Okay, y has no operations, it's all by itself, you just punch in the other side of the equation. 128 times 0.50 to the power of 3, and I got 16. Now in the assignment, okay, you got 4 problems. Just use 600 for your A, please. Just put million after the answer, okay, million. Just use 600, please. Don't try to add a bunch of zeros. This one you get a huge answer. Since it's grills, you don't really need a decimal. This should say grills here. And that's what we're finding, okay? Grills, and then I think the other ones. Remember to pay attention whether it's minus or plus.